Hello. Hola, Neil.
Hola.
Hi Neil, how are
¿Cómo
you?
estás?
Bien, ¿cómo estás? This is me live.
Todo bien.
How is everyone?
Bueno, estamos con Neil. Para la gente que se está sumando mientras, pueden dejar sus preguntas en Discord o acá mismo en el canal de YouTube. Las pueden hacer en inglés o en español. Y con Bruno vamos a tratar de contárselas a Neil para que nos dé su respuesta. So Neil, I think we have one question in Discord if you want to answer that, and then we can follow with more questions.
So I think it was just a comment in Discord. It was about the being more realistic and practical about about testing in general, and that was obviously one of the big messages there. That whatever you can do, be practical at the end of the day, because theory is not going to work well if you can't implement it.
In the first, in name of I think Matti and me, we want to appreciate your participation here. I consider it as a big value for us, for our community and conference. So thank you very much for joining. I have also some questions here in relation to most of all to test coverage, or I see on my daily work several times like people use the coverage of testing like a good metric of quality sometimes, or even to add it to the CI like as a restriction to deploy or something like that. And I would like to know what is your opinion about this, or how good do you think this metric is to measure quality on test?
Sure. First of all, thanks for having me. I appreciate the chance to talk about all of these things. A lot of people talk about code coverage. It's so easy to measure, and so it's very convenient for people to say we should just do it or we should do more of it. And there are times when it's valuable. It's more really of a proxy. It's not an actual measurement of any sort of code quality. It's just a measurement of how much testing is done. And even that isn't always clear. You can run through the code, but if you don't run through all of the edge cases or corner cases, you're still going to avoid, you'll miss catching problems that are in the code. And so it's good as a very rough measure, but it's only a very rough measure. And so it really depends a lot on your project. I worked on projects that are greenfield, and they're totally new code, and a lot of it was going to be thrown away. And for a long time, we had almost no test coverage, or we had whole sections of code that had no test coverage. And it was totally fine because it was throwaway code in essence. And so we didn't care about it. But there were some pieces of the code that we knew was going to last. And so in those areas, we focused on getting a reasonable amount of testing and test coverage. And so there really isn't a single answer, but there's a range of answers that's going to be beneficial. And so it depends on what scenario you're in. If it's code that's mission critical, it's going to need more tests, and having higher code coverage is likely to mean that you have better tests. It may or may not be sufficient. And so you still need to evaluate. One of the things that you can measure is how many bugs do you have, and relate the amount of bugs that you find in code and compared to the code coverage. Is there a relationship or not? And so if you can find a good relationship, how can you decrease the bugs? Is it by increasing coverage? Maybe in some cases. And if it's not, or if you increase coverage and it doesn't help you reduce bugs in the long term, then code coverage is really not likely to help you in that case. So unfortunately, I don't have a very simple answer to give you in terms of use it or not. You definitely should be very wary of using code coverage. It is good at one thing, but it's not generally the thing that we actually care about most. And so making sure to caveat and say, this is all that it's telling you. It might be telling you things are bad, but that doesn't tell you that things are good.
Okay. Yeah, I like this answer of mixing at least two metrics of amount of bugs and test coverage. I will briefly resume in Spanish, if that's necessary, I think. La pregunta fue más que nada relacionada a qué opinión tenía sobre el test coverage como medida de calidad de los tests. Y bueno, Neal menciona que es una medida muy burda sobre los tests, que puede no necesariamente implicar una calidad en el código. Sí, quizá la falta de test coverage te esté indicando que no sea bueno, pero el hecho de que el coverage sea completo no necesariamente te asegura de que sea malo. Y mencionó un caso en proyectos que estaban empezando, en donde el test coverage era muy bajo, pero estaba bien porque era código que se iba a reemplazar. Y mencionó también una forma de sumar una métrica al coverage de los tests, que es compararlos con la cantidad de bugs que uno encuentra en el código, ¿cierto? Okay, I'll briefly resume. We have a few questions also in Discord.
So one of the questions is, what would you recommend to people trying to teach testing to others, like students?
So the most important thing is to just do it. It's something that you'll learn and you'll get better at. And so one of the ways that you can motivate people to start doing testing is to point out the problems that that come up in normal coding practices and point out how testing can help avoid some of these problems. Do you want to translate that? And there's some more things I could say, or I could go on. Which do you think is easier?
As you prefer. You can go on.
So I guess one of the things that's happened to me several times is I've had various embarrassing mistakes before and things that could have been caught in testing. And so this is one of the reasons why I have grown to like testing more and more in order to avoid embarrassing situations. And so this is one of the reasons that you can also motivate people to say, let's do the simple things first, and then we can get more and more complex later, and then grow with your system. And that's kind of true of everything. Start small and simple, learn from there, and then go to the areas that is going to provide the most value to you in terms of testing. But always figure out how you can get the most important bits first. So when you start, what is the biggest thing that you're looking for? So is it to get an A on on your project that you're giving to the teacher to grade? Or is it that you're at your first job and you're looking to impress your peers or your manager? Things like that. What are the things that will be best? How can you avoid negative things, and how can you show positive things?
Okay. La pregunta estaba referida a qué recomendaciones le haría Neal a personas que están tratando de enseñar a testear o enseñar testing a otras. Bueno, la primera recomendación fue referida a empezar con situaciones sencillas o problemas comunes que se pueden dar cuando uno está programando. Y bueno, indicar justamente cómo los tests pueden ayudarte a evitar esas situaciones, esos problemas sencillos. Neal mencionó también que él ha cometido muchos errores tontos, digamos, por decirlo de alguna manera, o errores que se podrían haber evitado. Y bueno, la recomendación fue en este sentido, ¿no es cierto? Empezar enseñando cómo los tests te pueden ayudar a evitar errores sonsos, y después extenderlo a cómo también te pueden ayudar a agregar valor en el lugar en donde vos más necesitas. Si es para un proyecto de una asignatura, bueno, que puede pues, estar enfocado en ese sentido, o si está referido a un trabajo, o dónde está el valor que uno le quiere agregar al proyecto y cómo los tests pueden ayudar.
Okay, we have like one question or two from Discord. I will put it right here in the screen, and we have like a few questions in YouTube comments. You guys, girls, can leave you wherever you want, and we like put it here so Nick can read it and Bruno can translate it. So the next question is this one.
So I'll read the question first. What can you tell us from your experience with the Python language code, and what is the right size of testing for a project like that? So let's put it into perspective. The Python language is over 25 years old. It's used by at least hundreds of thousands, if not millions of people. Many, many people depend upon it for a great deal of robustness and reliability. And so testing in Python is really crucial, and it's important to get better and better at it. When I was heavily involved in Python, the tests were very weak at the time. And one of the things that I did was try to improve that and also do things like set up the build bots and get a lot of build bots running on different platforms to ensure that Python worked in all of the environments that we cared about most. And so these are the ones that people use. Lots of bugs were always reported. There were corner cases and things like that. Sometimes this was in documentation, but oftentimes it was also in code. And so the more that you can test it in all sorts of crazy ways, you can find more and more bugs. There were even bugs back before App Engine was released by Google. I was involved with Python and fixing some of the security holes with it. There were some buffer overruns and things like that. These were found by fuzz testing. And so even though Python was very mature at that point, nobody had ever reported those sorts of problems. There's always more bugs that are there. And so you always have to do more and more testing and get more and more sophisticated to find that the last mile of bugs, or last kilometer of bugs, the last little bits here and there, to make sure that you have the most robust platform. That means that you can spend less time doing debugging and fixing bugs and writing documentation and things like that. And you can spend more time adding features or doing fun things with Python.
Mm-hmm. Okay. We have an additional question related to coverage and metrics that is from Lekovi. I will post it also here.
Do you want to translate the answer, Bruno, or it's okay?
I think it's okay for this one. But we can move with the question from Lekovi. Besides coverage and the other metric mentioned, what other metric do you suggest to increase code base quality? I assume the other metrics is this bug counting that you mentioned in the previous question.
One of the important things is being able to trace bugs back to particular areas of the code. So is it a particular area of the code that is problematic because it's complex? Is it a person or a team that's adding bugs? Are there development practices that are poor, that are problematic? And so a lot of it comes back to understanding the nature of the problem. And so the metrics that you use, first and foremost, probably need to come from where do you think the biggest problems are, and then measure what those things are. So is it bugs that's a problem? Is it corner cases? Do you believe that it's a particular area of the code? Measuring anything that goes along with that. Ultimately, what are the defects that are found, whether they be bugs or anything else? In some cases, let's say you're developing an API, it may not be that it's a particular bug in the code, but rather it's the number of questions that you get from users that don't understand how to use the API. And that is still a defect. It's something that if the API were simpler to understand in a particular way, it would be less support for you. And so the metrics depend quite a bit on specifically what sorts of problems that you're having. And so it could be requests for help, it could be bugs, it could be crashes, it could be memory consumption. So it's a matter of measuring all of these sorts of things to figure out how is the system operating in production for users. And anytime that there's any sort of problem, anytime you need to do anything for maintenance, that is something that you can click and then you can count. And the idea is that as much as possible, if you automate that, and then you can put that on a dashboard, and then you can start looking at what are your measures of quality, because again, it depends on what is the code. Sometimes it's bugs, but sometimes it may be feature requests. Sometimes it may be lack of understanding of the APIs and so forth. So that's a partial answer to the question, I think. There's probably a lot more that we can go into, but let me stop there in case if you want to translate that.
Okay. In case that the answer go in this path, I understand from your answer that maybe the good observability of the system is also part of the answer.
Absolutely. Yeah.
Um,
Any and all observability.
Ujú. Bueno, la pregunta se refiere a qué otra métrica, aparte de la que habíamos mencionado antes del test coverage y la cantidad de bugs, puede sugerir Neal para aumentar la calidad del código, ¿no es cierto? Y bueno, su respuesta, una de las primeras fue identificar a qué aspectos del código se relacionan los bugs identificados, ¿no es cierto? Como para poder identificar la fuente, si es un módulo particular, si es una persona particular o si es un proceso lo que está generando los bugs. Y el resto de la respuesta fue referida a la observabilidad en general del sistema y a tratar de identificar métricas referidas a los problemas particulares que se están teniendo o al uso que se está teniendo, ¿cierto? Si el problema está referido a la cantidad de llamadas a una API o al uso de unos determinados usuarios, en fin, poder identificar métricas más específicas del sistema. Eso fue un poco la respuesta explicada brevemente.
Some other specific things, it might be latency that's important. It might be developer velocity that's important. Things like that. Again, any sort of thing that you can measure, is it uptime or what have you, as long as you can measure it, those are the things that are important. And it depends on what your software is doing and what your business is in terms of what is the quality and is it good enough quality or not.
Otras dos métricas que menciona son la latencia del sistema y la velocidad del desarrollo, y que todas las cuestiones que uno pueda medir sobre el sistema relacionadas al negocio en el que esté, y poder determinar si esas métricas indican un nivel aceptable o no, dependiendo del caso de uso, ¿cierto? Ok.
Bien, tenemos more questions. One previous about feature-space machine learning. So here is the question, Neal.
How do you recommend covering all feature space in ML intelligently? Hey, Axel. Axel and I worked together a while ago. So it's similar to code coverage. All of these things are challenges. And so focusing on the areas that matter most. There was an example in the talk about separating out testing the model from the business logic around it. And so as much as possible, you want to cover all of the features, but sometimes that's not always possible. And so you have to limit that. You can focus on the things that are most important. What are the features that are most commonly used? So focusing there. If you have a lot of data, you can run it through the system. And so you can see, do you get the expected results for each of the different features from some recording of live traffic to say, of the traffic that we received over an hour, all of these, we believe we get the right amount of traffic. We get the right answer for, even as we're modifying the software. But one of the most important things in all of this is changing only one thing at a time. So sometimes it's hard for us as software engineers because we want to fix everything all at once and we want to make lots of changes at once. But don't change the code and change the tests all the time. Don't change the test data all the time. Don't change your quality metrics at the same time that you're changing the code. So making sure that at each step along the way, you can do these things. You should do all of these things, but you should do them independently. What is the precision? What is the recall? What is the accuracy for ML? Those are all independent numbers. Don't change the code and change the test or the measurement of that or your data set that might give you a different indication. And so thinking about all of these things, making sure that you have a good set of data that you believe you can cover as many of the features as possible, and then grow it over time as you find anything lacking. So going back to other metrics, anything that you observe to be a problem in the system, anything that you need to do for maintenance, anything that's causing you additional time, those are the areas to work on improving and figure out how there was a hole in your coverage of testing. How do you improve that over time? And ultimately, how do you simplify your system so that you can either simplify the code so that it's covered by existing tests, or you augment your tests?
Cool. Okay, I think I will not translate that answer, most of all for respect to our audience in Spanish, but thank you for the answer.
I think I covered, like, if you focus, Neal, like in two approach. One, like a focus in the feature, important feature first, like for one step, and for the other approach, like doing one change at a time and don't change the data or the data on the test or the features at the same time. And regarding machine learning, like don't change the code or the test and have like a metric. Don't change the metric or change the code at the same time. So, en español más o menos sería las dos approach enfoques que recomienda Neal es, por un lado, es para atacar los tests o el coverage, es enfocarse primero en las features más importantes, en las que sean más críticas, sabiendo que no se puede hacer todo y no siempre se va a poder modificar o hacer test sobre todas las cosas. Entonces, enfocarse en lo que sea más importante. Y por otro lado, hacer cambios chiquitos, cambios únicos, no cambiar los tests y el código, sino siempre modificar de una cosa, no modificar los datos de los tests o los tests en conjunto con el código e ir cambiando de una parte y probando. Y por el lado de Machine Learning, relacionándolo a eso, más o menos el mismo approach, no cambiar el test o las pruebas que se hacen para validar el modelo y cambiar el modelo al mismo tiempo, sino conservar alguna métrica para que los cambios que se vayan haciendo se puedan ver reflejados. Something like that.
Gracias.
Okay, we have another question from Axel, actually, that I think is a very good question. So, how would you recommend creating a culture of testing and checking the alerts on bugs from bots, especially on companies?
So it's really, really important to focus on culture. If you do not have a testing culture, you are not going to get testing done. This was certainly my experience at Google. And so I did a lot of work a long, long time ago to change the culture at Google from one that was very light on testing to one that was very heavy on testing. And many other places I've gone, I've done similar sorts of things. So definitely one should not underestimate the importance of culture with respect to testing or anything else, really, when it comes down to it, because people behave within the culture. And so if you want testing, you need to have a strong testing culture. Now, how do you get a strong testing culture? Some of this goes back to a little bit the answer on observability, measuring things. What are the things that are important? Showing how well you are doing. This could be as simple as saying, what is your code coverage? It could be how many modules are tested. It could be how many bugs are there and other things like that that we've talked about earlier. And so the most important thing is having some sort of feedback loop. If people are not adding testing and you want people to add testing, what will it take to get people to add testing? People work according to their own motivations, and people like to game the system. So as much as possible, in order to get people to do testing, create some sort of game. How do you make it easier? How do you make it fun to add tests to a system? And so this will help change the culture in order to make it such that people are more interested in testing, always making it as easy as possible, making it as fun as possible. And then these are the things that will lead you to do more testing. And so rather than you dread getting that alert from a bot that says, oh, I got to fix this. It's more like, oh, cool. I've got a game and I can win this game by making a test. And this is the sort of thing that I think is really, really important, especially with testing when it's not very fun to begin with.
Okay. Bueno, la pregunta se refiere a cómo Neal recomienda generar una cultura de test, cultura de testeo, y en verificar las alertas de los bugs y demás, especialmente en empresas o en compañías. Y bueno, Neal apunta que es muy difícil, si no imposible, tener generar test o hacer buenos test si no hay una cultura de hacer estos test. Y una de las formas que apunta para motivar a la gente a que pueda escribir estos test es relacionarlo con una métrica y transformarlo de alguna manera en un juego, ¿no es cierto?, que puedan resolver las personas con test. Si la métrica no tiene el valor esperado, si hay un bug nuevo, que pueda haber una especie de feedback loop entre la métrica y la generación del test que motive a las personas a realizarlo.
Okay, we have
Okay.
like two questions. One is in Discord, like, can you recommend some material to learn about testing practices?
There is certainly a lot of material out there. It does depend a bit on how you like to learn. I will say that I am not a great person from learning from books, and so I'm not as strong in the books, although there are many books that are written about testing. And so if you're testing legacy code, I think it was Michael Feathers wrote a book about how to test legacy code that can be very useful. And I think it may actually have some of the similarities to some of the things that I said previously in the talk. If there are lots of other books, there was another book that I actually wrote a chapter in. It was called Beautiful Testing. That was more about a lot of essays about testing. It was also, if you want a more complete answer about testing the Python language, that was what I wrote about in the book. And so you can get more information in there. As I said, I'm not a great person for books, and so I tend to learn much more from actually doing and from existing code and examples. And so one of the things that you can do is find your 5 favorite projects. Which ones are good with testing, which ones are bad with testing. This can be within your own company and closed source software, or it could be an open source software. And which ones are doing well and which ones aren't. See if you can modify the tests, try it out, and see what works and what doesn't. And I think that way you can learn from what other people have done, and you can learn what works and what doesn't. For me, that's the general way that I learn, which I realize is a little bit harder in some respects, but I feel like I get a much more improved understanding of the system, and so much stronger learning if I actually do it rather than just learn it from a book.
Thank you for the answer. Bueno, la pregunta es ¿qué material puede recomendar Neal para aprender sobre prácticas de testing? Mencionó que él no es muy fan de aprender por libros, sin embargo nos recomendó 2, que bueno, los voy a poner, los busqué acá y los voy a poner en el chat de Discord de la charla. Y después también apuntó una forma más práctica, que es leer código o elegir algunos proyectos en los que uno esté interesado y enfocarse en tanto leer el código de otras personas como generar los tests para esos proyectos.
Okay, we have like one more questions. Question is this one. So what do you think that testing is considered a different area than writing code?
So let me first say I totally disagree that testing is separate from code. For me, if I'm writing code, it doesn't matter if it's production code or test code, it's all part of the same. And all of this comes down to that I'm trying to achieve a result. I'm trying to create something. I'm trying to get something done. And when I want to get something done, I want to do a good job of it. And testing is a way that helps me achieve that. And so it's all part of the same whole to me. As far as why do I think it's different, this might be, to some extent, going back to the earlier question, culture. And the culture in computer science, and if we look at the history of computing, there is the long road of the waterfall model of software development, where there are some people that do the requirements, there are some people, a different set of people, that come up with the design, there's yet a different set of people that do the implementation, and yet more different people that do testing. And if you go back a long time ago, these were very different people that were doing each of the different tasks. And so at that time, it was, I think, less software development and more just coding, and then all of these different areas. And I think that as a community, overall computer science and software development, we have kept some of that inertia where we just keep some of these notions where coding and testing and documentation, they're all different and they're all from different people. But in order for anything to work, any sizable software needs a level of documentation. It needs a level of testing. It needs the code. It needs to have a cohesive design, or all of this is going to fall apart. If you have any one of these that doesn't work well, you're not going to have nearly as strong of a product as you will if you have a good enough level of effort for all of these things. And so I agree that it is different, and I think I disagree with that. So I think that the thing to do is to figure out how we can make all of these things come together so that people view it as all part of the same whole. If we think about it as a coin, there's always two sides to a coin, and you can't separate them. And code, writing software is both writing production code and writing test code.
Bien. Bueno, la pregunta de Lecovi dice, ¿por qué pensás que testear o escribir test está considerado como un área distinta de escribir código? Bueno, Neal nos menciona que él está en desacuerdo con esto, que para él es parte de un todo. Menciona también tanto la participación de los test como del código y la documentación, y cómo la cultura influye también en esta concepción, ¿no es cierto?, del código y los test como áreas completamente separadas, y que para él tendrían que ser consideradas como complementarias de un mismo todo.
Bueno,
Okay.
y hemos llegado hasta aquí. This is all, Neal. If there's no more questions, thank you all for being here in this Q&A. And thank you, Neal, for joining us for this event, for this conference, for giving the keynote of this day. There is something you want to add to this?
So, gracias. I appreciate the opportunity to talk, and I enjoy answering any questions. I did in Discord answer or provide my email address in case if anyone would like to ask me any more questions as follow-ups. I'm always happy to answer them. And thank you again for the time.
Thanks to you, Neal. Thanks for joining, and we expect to have you in futures, the PyCon Argentina too. Hopefully in real and
Yes.
not virtual.
In person.
Okay. In person.
Perfect.
Thank you very much.
Bye.